think we just go one forward for me somehow. There we go. Okay, that's me. So my colleague Adele Ratcliffe came in and said, Mark, you always have more colorful slides than I do, so can you go first? Yes, well, certainly. So we switched up here. Thank you all for ASME for hosting today. I'm Mark Johnson, I'm the Director of the Advanced Manufacturing Office in the Department of Energy. I see a number of familiar faces in the crowd and some new faces, and so hopefully we'll spend a little time afterwards in talking if we haven't met before as well, and be happy to spend a little time afterwards. What I hope to go through today, it's, as some of you may or may not have known, is budget rollout week. So I was going to go through not only the NNMI, but also the Advanced Manufacturing Office and the Department of Energy's overall manufacturing strategy and give you a bit of an update on what we're working on and some of the new things that are coming through on that. Just some highlights on it. It's not comprehensive, but it's part of it. So first question you might say is, within the Department of Energy, where is it within our mission? How do we wind up tying that in? So there's three broad areas that we have in the strategic plan of the Department of Energy that we wind up working on. In this past year, I should say actually 2 years ago, we wound up publishing the updated, brought up to date the strategic plan of the department around three pillars that you wind up having. One is the science and technology around energy, and making sure we wind up having science and technology around energy. The second is an area of environmental management, especially of sort of legacy environmental management challenges. And then the third is around national security. Clearly, the area we wind up working in is in the area of the science and technology. So a couple things to highlight. For those of you who don't know this, the Department of Energy manages and has responsibility for overseeing the 17 national laboratories that are really a jewel in the crown of the science and technology that we have in this nation. How do we wind up utilizing those better? How do we not only, as Mike points out, developing not only the basic science and technology there, but then opening that up and making it so it's much more accessible to translating those breakthroughs into things that will create into manufacturing and jobs in the United States. And that's absolutely in our strategy to wind up working in that area. We also work with universities, laboratories, nonprofits, small and large businesses across the country looking in areas of supporting science and technology. We do this through our various funding offices. We have the Office of Science, that's the largest sponsor of physical science in the nation. We have the applied offices, where I'm in the Energy Efficiency and Renewable Energy Office, where advanced manufacturing is. We also have our fossil energy, our nuclear energy, ARPA-E, and our Office of Electricity as well. And I'm going to come back to our Office of Electricity and some of their roles in manufacturing in a couple of minutes. I'll draw your attention to a couple of things we wind up doing. First of all, within that, we wind up having our energy efficiency and renewable energy strategic plan, and we have two areas where manufacturing most prominently come into that. One is developing technologies for broadly applicable energy efficiency technologies across the manufacturing sector. So about a third of all energy winds up going into manufacturing. How do we use technology to wind up making it so we use that most effectively as possible? But just as importantly, we have the area of platform technologies. How do we wind up making sure that we are competitively manufacturing the new clean energy technologies, the new technologies that are coming out in the development of our offices, and make it so we can most competitively manufacture those in the United States? And so we have certainly within our mission how we wind up using science and technology to accomplish that mission. I'll draw your attention to a couple of reports that came out of the department this past year. One's our quadrennial energy review that's looking at what are challenges on especially infrastructure for transmission, distribution of the power grid, and what are the opportunities for investment in those areas. And then the second is looking at our quadrennial technology review, where we went top to bottom throughout the entire department and said, where are those areas for technology focus, and how do we wind up having our strategic plan for the next 4 years around that? Of importance in that, there's an entire chapter focused on manufacturing, particularly manufacturing on clean energy technologies. And that really strongly becomes the framework for where things within the Department of Energy's mission around manufacturing. And identified really 14 high-level topics you can look at. These come into process technologies, material technologies, and as you pointed out, the importance of information technologies as that's getting more and more important on how we wind up manufacturing competitively and efficiently and productively in the 21st century. So those 14 topics really, if you want to do some great background work on how we can wind up working in these areas, these are posted on the web. A lot of public engagement on this, open input, peer-reviewed, all that good stuff to wind up making it so It's really something that represents what the outside world is saying. This is what the Department of Energy should be working on and where our opportunities are. Within the Advanced Manufacturing Office, we really have three pillars of how we wind up conducting our work. We look in areas of technical assistance, where there's a invented technology that we need some dissemination of knowledge out there. We look at R&D projects, where you have individual R&D projects for companies and universities and laboratories for maturing some of those basic research technologies into these manufacturing areas. And then the third area is really looking at these consortia in our facilities. And these are place-based innovation opportunities. And the National Network for Manufacturing Innovation is really one of the jewels within those sort of activities we wind up doing. So how do we bring people together working in a coordinated way under this Manufacturing Institute model so that we can really address some of these key technical challenges? As Mike pointed out, I'm going to take a step back here before we get into the NNMI and talking about our technical assistance. One thing to point out broadly to the manufacturing community, it's the 40th anniversary of our industrial assessment centers. What this does is a university-based program where the students wind up going out and providing energy assistance and energy audits for small and medium-sized manufacturers. They've done 17,000 companies that they've worked with over the past 40 years and 109,000 audits. Literally in every neighborhood in this country, it seems that there's been some impact on it. This is a program that goes through every 5 years, a competition, and over the next year is the time when the next competition is moving forward on it. So we're looking forward to working with the community around that. We have things like our Better Plants program. This represents 12% of the energy spend in the manufacturing sector. These are getting companies to wind up committing to energy efficiency targets and reporting their progress towards those goals. So that's the areas of our technology assistance. In our technology R&D projects, we've got a couple of areas we wind up working on. And really what the focus is how do we wind up, in some ways, unleashing some of these science and technology capabilities we have within our national laboratory system. So a couple of programs I'm going to wind up highlighting we look at. One is a program where we have competitive solicitations. This is led through Lawrence Livermore National Labs, but working with Berkeley and Oak Ridge, Lawrence Berkeley Labs and Oak Ridge and some of the other labs for our high-performance computing for manufacturing. The picture there is actually a Professor Chen doing visualization of the modeling and simulation of operations of a blast furnace. And one steel company said, if we wind up applying these, we can save tens to hundreds of thousands of dollars per day in just how we operate our blast furnace technology. And to give you a comparison, blast furnaces and steel making in the United States still consume about 1% of the primary energy used in the country. So it has a big wedge it can potentially affect as far as how it winds up doing that. Another area, so this is unleashing the massive high-performance computing. DOE has oversight of about 5 of the 10 most powerful computers on the planet. So how do we wind up utilizing those assets and working with manufacturing on their relevant problems? We also have through our national labs, things like our manufacturing demonstration facility down at Oak Ridge National Labs. This partners with America Makes up in Youngstown, Ohio. And one of the things we did this past year is wind up developing the tools and the capability to wind up doing this demonstration of a 3D printing of an entire vehicle. Our NNMI activities, we have 3 institutes, 2 that have stood up. The Power Electronics Institute down in North Carolina. I should say the place-based it's based in North Carolina, and there's really 3 or 4 different states that have key nodes within that. So there's one in California, there's a bunch of activities up in Massachusetts and New York that are all associated with that Power Electronics Institute, working together in these silicon carbide and gallium nitride activities. The Institute for Advanced Composite Materials Innovation is based down in Knoxville, and what was neat about this is it was 5 different states going up and down that I-65 corridor, coming together and saying, look, we need to really build out this composites area. It's applicable in vehicle technology, it's applicable in future wind technology, in tank technology. Let's work together on this. And since that stood up over this past 6 months, it's wound up having 98 different companies have committed and signed into the participating in the consortium. So that's really exciting. We have our smart manufacturing solicitation that is live right now. Actually, it closed about 2 weeks ago. I should say it's in merit review right now, so can't really talk about that much, but that's really looking at real-time process control and this information technologies. And then the other area we've done a lot of work over the past 4 to 5 months is held a series of 5 different open workshops on topics that we'd identified through the QTR as potential future institutes. Those workshops have actually resulted in the workshop reports that are coming into my desk right now and will be published in the next coming weeks or so, that really brought in a lot of industry engagement so we can wind up hearing from you on an open basis. What are the technical challenges where we should wind up really focusing some of these manufacturing institutes within the Department of Energy? So I've got some detailed slides here for the Power Electronics Institute, the Composites Institute, and the Smart Manufacturing Institute. One thing coming back to the FY17 budget, we have a request for one additional institute within the Advanced Manufacturing Office in DOE. And as well, we've worked with our colleagues in the Office of Electricity to have a request for one manufacturing institute in the Office of Electricity, working together with them to make sure it's consistent and a part of the whole network, but really focusing in this area of manufacturing relevant to grid-related issues as well. So with that, I think we're, one last thing to look at. Looking in the National Lab System, and this was an effort that was pioneered out of Lawrence Berkeley National Labs this past year, which is to say, how do we wind up opening the doors to small manufacturers to make them much better places for people that are wanting to do startup companies in the energy sector being associated with the National Laboratory. So we've piloted this program called the Cyclotron Road program, Cyclotron Road being the road into Lawrence Berkeley Laboratories, where innovators with nascent ideas wind up coming in, sort of testing out the science and technology within the laboratory that they came in with, and say, how do we build a business around that? And then bringing together partnerships with the private sector so that those then can accelerate their ramp out of that situation in the national labs. So with that, thank you very much.